So let's take a closer look at valence bond theory. In valence bond theory, remember we said that bonding is explained as due to overlapping of atomic orbitals between two nuclei, the two atoms. And when the overlapping of these atomic orbitals lead to a high electron density along the line of centers between the two nuclei. For example, imagine you have two hydrogen atoms. If you have a 1s orbital from this hydrogen and a 1s orbital from this hydrogen, and if they are in phase, in other words, where they overlap, they both have the same algebraic sign, then you get what's called positive interference, constructive interference, and so you get a high electron density between the two, and so that explains bonding between the two hydrogen atoms, and so we say we classify that bonding as sigma bonding. So bonding along the line of centers of two atoms is called sigma bond. So we say this is a 1s to 1s overlap, this particular sigma bond between two hydrogen atoms in an H2 molecule. Now, in some atoms, you can have some pairs of atoms can have double bonds and triple bonds, as we've seen when we drew Lewis structures. Now, the second and the third bond, okay, are said to be due to pi bond. So the first bond is always due to the sigma bond, that's the bond along the line of center. You can have a region of high electron density above and below your neighboring atoms, and that would be a pi bond. Okay. A second pi bond can be a region of high density in front of and behind. Okay, if you look at these as your two atoms right here, this one and this one. Okay, so if you have two atoms here, okay, a second pi bond would consist of regions of high electron density. Imagine one in front of this pair of atoms and one behind the atoms. Okay, so those are your pi bonds. That would explain the second and the third bond in your pi, or in your triple double bond and your triple bond. Okay, let's just summarize what we have with this example. How many sigma and pi bonds are between the carbon and the nitrogen in HCN? Well, there's a triple bond here. So the first bond between them is a sigma bond. So you have one sigma bond, okay? And you have two pi bonds. The second and the third bond in a triple bond are pi bonds. And we can say that that would be due to overlapping p orbitals in the neighboring atoms. So you have, for example, if this was your z-axis right here, okay, then your pi bond would be due to px orbitals overlapping, okay, and py orbitals overlapping. Okay, so that gives you two pi bonds, and then you have a bond between the carbon and the nitrogen